Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And I'm Jeetendra Dixit. Here is my profile. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for the last 11 years. So I teach mathematics, and before we begin today's session, let me check my voice. Right. Yes, so now let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform. And if you're preparing for IIT, then you can have two types of subscriptions on Unacademy. One is Plus subscription, another is Iconic subscription. So when you take Plus subscription, you get access to daily live classes of all the educators who are teaching for IIT-JEE. You can also watch their live sessions as well as recorded sessions. All these live sessions are pre-planned, so everything you can see the schedule of all the upcoming lectures in well advance. Your live test and quizzes will also be accessible to you. So this is unlimited access which you get once you have the subscription. All right, so this is Plus subscription, and these are the subscription charges. You can subscribe for 1 month, 3 months, 6, 12, and 24 months. 12 months it is 38,500, and 24 months it is 56,000. Hi. Okay, so you get 10% discount using the referral code JEET1. So use this code, and your final payment will be 34,650 for 12 months and 50,400 for 2 years, 24 months. Okay. Now this is Iconic subscription, which you get in which you get all the benefits of Plus, and apart from that, you get a personal coach who will guide you throughout your preparation for all the top exams like IIT-JEE, JEE Main, and Advanced. And your test analysis will be done in a personalized manner. Your personalized feedback will be given to you to improve your time management and exam approach. Study planner will also be customized, and bi-weekly reviews will be given highlighting your progress. Now 12 months that is 56,000, and after 10% discount you'll have to pay 50,400, and for 24 months it is 86,000, and that too after 10% discount it is going to be 77,400. Now this is Unacademy's learning app, which you can download from Play Store, and after downloading this you can start your preparation. You can start attending special classes. The special classes are completely free. So you can attend unlimited special classes every day. A lot of educators take special classes, so just attend the special classes. These are live classes, and you can see these classes are exactly the same which you get in Unacademy by taking Unacademy's Plus subscription. So those live sessions are exactly same as special classes. So you can see how interactive this platform is. You can you can chat with your educator. You can send your doubts. You can ask your doubts apart from dedicated doubt sessions. All right. So now we will begin today's session, which is differential equation. First order linear differential equation we'll do today. All right. So now let me explain first order linear differential equation. All right. So this is called linear differential equation. If you write dy by dx plus y into fx is equal to gx. Okay, this is called first order linear differential equation um, in dy by dx. So order you can see is 1 and degree is also one of this equation, and equation is written in this particular form. So how to solve it? Let me tell you the solution of this differential equation. First of all, multiply dy plus y fx dx is equal to gx dx. Now you multiply this equation by integrating factor. Multiply by integrating factor, which is basically integral e raised to integral of fx dx, right? And in this, if you put, it is e raised to integral of fx dx into dy plus y into e raised to integral of fx dx into fx dx and is equal to gx dx. See what happens when you multiply by this integrating factor. So we define integrating factor like this, and the purpose of multiplying this is to make this expression exact derivative of something. Exact derivative means, we'll discuss this exact derivative also. Suppose you have x dx, then you can write this d of x square by 2. This is called exact derivative, right? If you have x dx plus y dy, then you can write d of this x square plus y square by 2. This is called exact derivative, right? Similarly, if you have dx dy plus y dx, this can be written as d of xy, right? So there are many expressions which you can write in terms of exact derivative. Similarly here also, if you see, this is going to be, wait a minute. Alright, so you can see this can be written as d of y into e raised to integral of fx dx, right? And this is equal to gx dx. Now you can integrate, because this is a function of x with dx, so you can integrate this easily. And now here you need to integrate 1 with respect to any function. You can integrate 1, right? So integration of 1 with respect to t is t, integration of 1 with respect to fx is fx. So integration of 1 with respect to this function is going to be y into this function as it is. So this is e integral of fx dx, and right hand side it is going to be integral of, oh, so I forgot to multiply this integrating factor right hand side also. Let me write it here. When we multiply it integrating factor, we'll multiply it both sides, okay? So of course we need to multiply it both sides. So it is there also, integral of e raised to integral of fx dx into dx. So it is going to be integral of gx into, I'm writing this integrating factor, okay, dx. So we solve for this and then we write the answer. So this equation can be written as y into integrating factor is equal to integral of gx into integrating factor, okay, dx. So actually this was the process which you need to understand. Just to understand, I'm telling you this process. You can skip it and directly write this, okay? Once you identify it's a linear differential equation of in this particular form, then directly start with this, okay? Directly start with this. But before starting, you need to calculate this integrating factor, okay? So calculate this integrating factor and then start with this. So I'll tell you how to do it. Let me tell you how to solve this differential equation. So let me give you one example. Suppose you have dy by dx minus x into y is equal to x. All right, the simple differential equation. Now let's see. So in this case, you can see this is a linear differential equation. If I find integrating factor, that is going to be e raised to integral of minus x dx, all right, and then you can write e raised to minus x square by 2. So this is the integrating factor. Okay, now you can write your solution y into integrating factor. So y into e raised to minus x square by 2 is equal to integral of x into e raised to minus x square by 2, right? X, this function into integrating factor dx. Okay, so I'm just copying this formula. Y into integrating factor is equal to gx into integrating factor, okay, dx. So this part you can do now. Integration of minus x square, its derivative, you can do this. This might multiply minus 1 and minus 1. So you can see this is, if you put minus x square by 2 is equal to t, then minus x dx will be dt. So it is minus of e raised to, okay, directly you can integrate. So it is minus of e raised to minus x square by 2, all right, direct integration plus c. So here's the solution. Now I've got the solution. This is the answer. You can leave answer in this particular form. All right. Now I'll give you some questions. Let's practice some questions now. So now here's one example. In this example, you have dx plus, sorry, dy by dx plus cos x into dy by dx plus sin x into y is equal to sec square x. Okay, so this is the differential equation we need to solve. So try this one. All right, so let's solve it. It is dy by dx plus, so it is sin x upon cos x is tan x into y is equal to sec square upon cos x. So sec square, it will be sec cube x, right? If you divide by cos. Now you have got this equation in the form of dy by dx plus fx into y is equal to gx. The coefficient of dy by dx should be 1. So I've got in this particular form. Now you can do the integration. So it is dy by dx. First you write integrating factor. So integrating factor is going to be integrating factor is going to be integral of e raised to integral of tan x dx which is e raised to ln sec x, and that which is equal to sec x only, right? So now your answer is y into sec x is equal to integral of sec raised to 4x dx. All right. So now you can sec raised to 4 can be written as sec square x into 1 plus tan square x dx, right? And then further you can write this sec square x dx, one integral, plus sec square x into tan square x dx. This is your tan x, plus this is, if you tan x is equal to t, sec square x dx will be dt. So it is going to be tan cube x, right? Tan cube x by 3. I'm directly integrating it again. So you can directly integrate it. This is going to be your answer. All right. So I hope it is clear. Let me explain what have I done. So first of all, we wrote the equation in the form of dy by dx plus fx into y is equal to gx, and then dy by dx plus fx y is equal to gx. We compared with this and wrote integrating factor. Integrating factor is e raised to tan x dx. So integral of tan x is ln sec x, and e raised to ln x is x. So sec x we have written as integrating factors in simplified form. Then we wrote y into sec x is equal to sec raised to 4x dx, and this sec raised to 4 can be written as sec square into 1 plus tan square dx. All right, and then finally integrate this. Now the next one is dy by dx. Try this one, plus y cot x is equal to cos x. Alright, so let's solve it. So if we solve it, then integrating factor in this case is going to be integral of integration e raised to integral of cot x dx, and that is going to be e raised to minus ln sin x, which is basically cosec x, right? So now your answer is y into cosec x is equal to integral of cot x cosec x dx, and integration of cosec x cot x is nothing but minus cosec x plus c. So that is your answer. This was pretty simple. Okay, quite straightforward. Now let me give you another one. So next one is dx plus x dy is equal to e raised to minus y sec square y dy. Alright, so try this one now. Alright, let's solve it. So in this case, if you divide by dy, it is going to be dx upon dy. Now this is a differential first order linear differential equation in x, alright, dx upon dy. Plus you can see this will be x remaining here is equal to this function of y. So let it be function of y minus e raised to y sec square y. So whenever you have differential equation in dx upon dy, then how to solve it? Just everything will be changed to y. Like let me write it first. So if it is dx upon dy, and then it will be function of y into x and is equal to function of y here also. And integrating factor is now going to be e raised to integral of f of y dy. Okay, this is going to be the integrating factor. So in this case, integrating factor is going to be e raised to integral of 1 dy. which is e raised to y. Then final, it is going to be x into e raised to y is equal to e raised to y into this function, integrating factor into e raised to minus y sec square y dy. All right, this is going to be 1 now, so it is integration of sec square y dy, and this is going to be now tan of y. So it is x e raised to y sec tan of y plus c. This is your final answer. All right, the next example is going to be let's solve this one. Dy by dx minus tan of y divided by 1 plus x is equal to 1 plus x into e raised to x sec y. Okay, so this is the next example. Try this one. All right, so it is all right, so let me tell you the concept first. Now this is convertible to first order linear differential equation. So any such equation which is written in the form of dy by dx plus say f dash g h dash of y dy by dx into fx into hy is equal to gx. All right, so first what we do, we put, in this case we put h of y is equal to t. All right, then you can see h dash y dy by dx we are differentiating it with respect to x. Okay, so h dash y into differentiation of y will also come, so that is dy by dx is equal to, right hand side it is going to be dt by dx. Okay, so you can see this whole thing can be replaced by dt by dx. Okay, and this h of y can be replaced by t is equal to gx. So now you can see this is first order linear differential equation in t, so it can be written as integral t into integrating factor. So integrating factor is e raised to f of y dy, sorry, f of x dx, f of x dx. This was f of x dx is equal to integral of gx into integrating factor, again e raised to whatever this value comes out after integrating, and this whole. So you can see this is a function of x, this whole thing is a function of x, and we need to integrate it with respect to x. So we can solve it further. It's now a simple integration and we'll get the answer. So in this, let's see if it is like that, but it's not visible like that, so we'll have to divide by sec. So if you divide by sec, that means you're multiplying it by cos. You'll get cos of y dy by dx. I'm just removing this function from here, function of y. So to remove this, I'm multiplying cos y. So I'll get cos y, and then tan y into cos y is nothing but sin y upon 1 plus x is equal to 1 plus x into e raised to x. So now you can see that integration e raised to, so first of all we need to substitute sin y is equal to t, right? Yes. So sin y is equal to t, and this will give you cos y dy by dx is equal to dt by dx. This is now dt by dx, so this is dt by dx minus now the sin y will be t, so 1 upon 1 plus x into t is equal to 1 plus x e raised to x. Now you need to integrate it. Okay, so take integrating factor. So integrating factor is going to be integral e raised to integral of minus 1 upon 1 plus x into dx. So that is going to be e raised to minus ln of 1 plus x, which is actually 1 upon 1 plus x. Okay, so now we have got this integrating factor, and it is going to be dt upon, okay, directly let's write the answer now. Let's write the solution of this differential equation. So that is going to be t into integrating factor. Integrating factor is 1 upon 1 plus x is equal to t into integrating factor into integral of 1 upon 1 plus x into 1 plus x e raised to x dx. Alright, and this 1 plus x and 1 plus x will get cancelled, and integral of e raised to x is e raised to x plus c. So it is t upon 1 plus x. That is going to be your answer. Alright, so I hope it is clear. Alright, so let me give you another example to solve. I'll do some mixed questions. Now we have this Bernoulli equation. Okay, so let me tell you this Bernoulli equation also, dy, which is convertible to first order linear differential equation. So it is dy by dx plus some function of x into y. is equal to gx into, now it is y raised to n here, y n is more than or equal to 2. Okay, n is more than or equal to 2. So now this is called a Bernoulli equation. Now see how to solve it. So what we do in such equation, we divide by y raised to n, and after dividing by y raised to n, it is going to be y raised to n dy by dx plus fx into 1 upon y raised to n minus 1 is equal to gx. Alright, now see what we do. It is 1 upon y raised to n minus 1 is equal to t. This is what we put y raised to 1 upon y raised to 1 upon y raised to n minus 1 is equal to t, and then differentiate it. Sorry, y raised to n, not n minus 1. Y raised to n. This is equal to t. Wait a minute. No, sorry. It was right. Y raised to n minus 1. Okay, and then we differentiate it. So after differentiating it, it is going to be y raised to minus of n minus 1, and this will come, if we differentiate it, it is going to be this minus 1. Okay, and dy by dx is equal to dt upon dx, and this is going to be minus of, or you can write 1 minus n divided by y raised to n dy by dx is equal to dt by dx. So it is going to be dt by dx into 1 upon 1 minus n plus, this is going to be fx into t is equal to g of x. Now you can see this is first order linear differential equation. So it is dt upon dx plus n, 1 minus n you can multiply, it's a constant, so you can club it with fx. Okay, into t is equal to 1 minus n gx. Okay, so now you can see, this is a first order linear differential equation, and you can write integrating factor. Integrating factor is going to be e raised to 1 minus n into fx. As I told you, this 1 minus n can be clubbed with fx. You can write the integrating factor. All right, so now let's solve an equation. Okay, solve it. Solve this particular equation. Alright, so let's solve it. First we'll divide by y raised to 4. So if you divide by y raised to 4, it is going to be 1 upon y raised to 4 dy by dx minus sine of x. This is 1 upon y cube, and this is going to be tan x as it is. Okay. Now we put 1 upon y cube is equal to t. And after differentiating, we'll get minus 3 upon y raised to 4 dy by dx is equal to dt by dx. Or you can write 1 upon y cube dy by dx is going to be minus 1 by 3 dt upon dx. So if I put in this, it is going to be now 1 upon y raised to 4. So it is going to be minus 1 by 3 dt upon dx, which is minus okay, so I have multiplied this equation by 3. Now you can see your integrating factor. So your integrating factor is going to be e raised to integral of 3 sine x, alright, dx. Okay, let me change this question slightly. Instead of giving tan x, it should be cot x, then you will be able to do it. So I'm changing this right hand side function. It is cos x, alright. It is sine x only. So now you can write it is going to be e raised to minus cos x 3 times dx. This is the integrating factor, and after doing that, now you can write the solution. So its solution is going to be t into integrating factor, so e raised to minus 3 cos x is equal to integral of 3 times of sine x into e raised to minus 3 cos x. Now you can integrate it, alright. Now you can put minus 3 cos x is equal to 3, so minus 3 cos x ka derivative is plus 3 sin x. So this 3 sin x is going to be derivative exact. So let's write this 3 sin x, and this is going to be final answer is going to be t e raised to minus 3 cos x is equal to 3 sin x, alright. 3 sin x, e raised to, this is going to be e raised to minus 3 cos x as it is plus c. So this is your answer, alright. This was the differential equation. Now the next question is dy by dx is equal to y upon x plus y square upon x square. Okay, so you can solve it the way you want. I have told you all the methods now, so you can use any method, whatever comes in your mind first. Alright, so you can see this is a function of y upon x, the homogeneous equation, so you can do it using homogeneous equation also. So in this you need to put y upon x is equal to t, as I told you yesterday. Then y is equal to tx you can write. So now you can integrate, so this differentiate, so dy by dx is equal to t plus x dt upon dx. Alright, so now you can write t plus x dt by dx in this is equal to t plus t square, right? This t and t will get cancelled. That's very easy to solve it. That is dt upon t square is equal to dx upon x. Alright, now you can integrate it. So 1 upon t square can be written as minus 1 upon t is equal to ln x plus c. Okay, so now you can put the value of t. T is y upon x, so it is minus x upon y is equal to ln x plus c. Now let me give you another equation to solve. So it is x square minus 1 dy by dx plus 2x dy by dx is equal to 1 upon x square minus 1. I'm sorry, 2xy, not dy by dx. 2xy. Alright, so try this one. This is a very good question. What do you want me to repeat, Raghav? Hello, Dev. This question or solution of this question. We need to, this is the first, I was teaching first order linear differential equation, which is of this form dy by dx plus fx into y is equal to g of x. To solve it, first you need to find integrating factor, which is e raised to integral of fx dx. And after doing this, the solution of this differential equation is y into integrating factor, y into this e raised to integral of fx dx is equal to integral of this gx function, gx into integrating factor, which is this e raised to fx dx. So to solve it, first of all, you need to bring this equation in this particular form. So you can bring this equation in this particular form by dividing the whole equation by x square minus 1. So it is going to be dy by dx is equal to plus 2x divided by x square minus 1 into y is equal to 1 upon x square minus 1 the whole square. Alright. Then you can find your integrating factor. So integrating factor is going to be e raised to integral of 2x upon x square minus 1 dx. Okay. And that you can write e raised to, you can see this is f dash x upon x. So you can write ln of this x square minus 1. And further you can write this x square minus 1. So this is your integrating factor, right? Now you can write the answer. So y into integrating factor, which is x square minus 1, is equal to integral of this gx, which is 1 upon x square minus 1, into integrating factor, which is x square minus dx into dx. This will get cancelled. You'll get 1 dx, which is x plus c, and that is your answer. All right. So this is your answer. All right, got it? Now you have another question. This is 2x minus 10 into y cube into dy by dx is equal to, plus y is equal to 0. Solve this differential equation. Are you solving it? All right. Okay, solve it. Yes, reciprocal. You can write this differential equation in dx upon dy. So multiply by dx upon dy. So it will be y dx upon dy plus 2x, okay, is equal to 10 y cube. Now you can divide by y, so you can write this dx upon dy plus 2 upon y into x is equal to 10y square. Okay, so now you can integrate. So integrating factor is going to be e raised to integral of 2 upon y dy, right? This is in the form of dx upon dy plus f of y into x. Just interchange x and y is equal to g of y. Okay, so integrating factor is going to be e raised to f of y dy. Okay, so that is going to be e raised to integral of ln of y square. 2 ln y means ln y square. Okay, this is integration, and e raised to ln y square is nothing but y square. Okay, the final solution is going to be x into integrating factor is equal to integral of g of y into integrating factor dy. So this x into integrating factor is y square is equal to integral of g of y. So what is g of y? G of y is this function 10 y cube into y square dy. So you can integrate y raised to 5. So it is 10 y raised to 6 divided by 6 plus c. This is the answer. Got it? Got it? समझा? y raised to 4 आएगा. This is y square, this is y cube. So it is y raised to 5, and then y raised to 6 upon 6 is the answer. Ten y cube into y square is y raised to 5. So integral of y raised to 5, we are integrating, not differentiating. So it is y raised to 5 plus 1 upon 5 plus 1. What's the problem? Not getting this. Oh, actually, yeah. Sorry. Yes. ठीक है. Yes, I did this mistake. I should have copied it from 10y square, not y cube. Yes. I copied from this one while it was 10y square, right? So it is going to be 5 divided by 5. Okay. So final answer is going to be this. xy square is equal to 2 y raised to 5 plus c. Now, okay. Yes. Got it. I saw the mistake. Now it is going to be sine y dy by dx is equal to cos y into 1 minus x cos y. Now try this one. This is a very good question. So are you making a differential equation in dy by dx or dx upon dy? That is an important point in this question. Now, this is, are you getting what to do? Are you getting, Mr. Raghav? Or shall I give you the hint? Shall I give you the hint? Dx by dy, but that won't work. This is convertible to linear differential equation. That means I'll have to put some function is equal to t to get the first order linear differential equation. Convertible to first order linear differential equation. And you'll have to make it in dy by dx only, not in dx upon dy. So first write like this, sine y dy by dx, and bring this cos y to left hand side is equal to, you can write minus x cos square y. Okay. Now think. It is convertible to linear differential equation. That means some function of y you need to put is equal to t, some function of y. So what is that function of y? If you divide this equation by cos square, divide by cos square y, then sin y upon cos square y is tan y sec y, dy by dx as it is, minus cos y upon cos square is sec y is equal to minus x. Okay. Now you can see this sec y, you can put sec y can be put is equal to t, and differentiation of sec y is sec y tan y dy by dx. We are differentiating with respect to x is equal to dt by dx. So this whole thing will become dt by dx. Okay, dt by dx minus t is equal to minus x. Now you can see this is a first order linear differential equation in t. So its integrating factor is going to be e raised to coefficient of t, which is minus 1 into dx. So it is e raised to minus x. So now your solution is going to be t into integrating factor is equal to integration of minus x e raised to minus x dx. Now you can integrate it easily. So it is first into integration of second and minus plus integration of differentiation of first, integration of second. I have already put plus sign. Now you can further integrate it. So it is x e raised to minus x minus e raised to minus x. Minus that will also become plus. Then plus c. And there is t. What is the t? What is t? T was sec y. So sec y into x. Alright. This is your final answer. So I hope you got it, huh? Now one more question. 1 plus y square into dx is equal to tan square of y minus x dy. Now try solving this. I updated, but I don't know. I haven't got any information. Let me check. You can't see session there, plant session there. Premier I can do one, so I have. All right, I'll update. See if they have planned it or not. Otherwise, I'll record some sessions for vector. I'll premiere some sessions for vectors, okay? No, this is a good question. Now see, in this you need to make a differential equation in x or in y, okay? This, be careful in that. All right. See what I do. In this divide by dy. So you'll get 1 plus y square dx upon dy. Then you can write minus is equal to x minus x plus tan inverse y, right? Minus x plus tan inverse y. Okay. So if I divide by 1 plus y square, I can write dx upon dy minus 1 upon 1 plus y square. Now it is simple. Plus like this into x is equal to tan inverse of y. So now this is written in the form of dy by dx plus some dx upon dy, dx upon dy. Some function of y into x is equal to another function of y. So its integrating factor is going to be e raised to minus of 1 upon 1 plus y square dy. So that is e raised to minus of tan inverse of y, right, plus c. All right, is that all right? Oh, this will be 1 upon 1 plus y square here also, okay? Now it's all right. Now you can write the solution. So x into integrating factor e raised to minus tan inverse of y is equal to integral of this function, which is tan inverse of y upon 1 plus y square and e raised to minus tan inverse of y dy. Now I can put minus tan inverse y is equal to x. So minus tan inverse of y is equal to u. So 1 upon 1 plus y square dy is equal to minus du. All right. So this solution is going to be x into e raised to minus tan inverse y is equal to, this is integral of, what will it be? So minus du, and this is u e raised to u, right? So now you can write the answer. So this x e raised to minus tan inverse of y, and integration of u e raised to u is u e raised to u minus e raised to u, right? Plus 3. You can put the value of u, so that is e raised to tan inverse of, what was that? Minus tan inverse of y with minus sign, and minus minus plus tan inverse of y e raised to minus tan inverse of y. Okay, that is the answer. So basically you can divide by e raised to minus tan inverse of plus c plus integrating constant. Yeah. So integration complicated nahi, but differential equation, no, not complicated. Generally they don't give complicated integrations in differential equation, but differential equations might be complicated, and sometimes it becomes difficult to identify which kind of differential equation is this. Like y dx minus x dy is equal to uh, plus y square cos x dx is equal to 0. This is a differential equation. Okay, now in differential equations they give generally integration is not very difficult, so equation might be difficult. Generally integration is not difficult in, yeah, even in advanced they give smart questions on differential equations. Integration generally remains easy. Identifying the form and proper substitution, that is an important point in equation. Okay, so try this particular sum. This is our last sum today, and we'll continue this concept tomorrow. I'm not sure if they will send me the ritual, then I'll take it. If I'll not get, then if I'll get the information, then I'll take it because I have already updated on the sheet. So maybe by 6 p.m. by 5:45 I'll get to know. Most probably I'll take it. Okay, I'll message you on Educator's app. Okay. We'll practice some triple products. All right. Try this sum. So do you know these exact forms? I was explaining this earlier. Whenever you have x dy, okay, what is exact form? Basically, we'll practice this tomorrow. Just telling you some details of it today. X dx. This can be written as d of x square by 2, right? This is called writing this in exact form. Writing this in exact form. Like x dy plus y dx. If you have this expression, this can be written as d of xy. Similarly, if you have x dx plus y dy, this can be written as d of x square plus y square by 2. These three are very important. The third one I'm writing, x dy minus y dx divided by x square. This is d of x upon y, y upon x. And if you have y dx minus x dy divided by y square, this is d of x upon y, right? So in this way you can write the differential expressions in exact derivative of some function. Like in this, you can see this y dx minus x dy. So by looking at this, you can easily identify that you can divide it by y square, and y square is also there in the second term. So y dx minus x dy divided by y square plus cos x dx. That means we have divided the whole equation by y square. All right. So this is going to be d of x upon y plus cos x dx is equal to 0. Right. Now if you integrate, it is going to be integration of 1 with respect to x upon y is x upon y, plus integration of cos x is minus sin x, plus c is equal to 0. Have you got it? Have you got it, Raghav? All right. Then we'll continue tomorrow. Differential equations. Exact forms. All right. Raghav, thank you very much. Be there on